For this assessment, you were asked to produce a multiplication table from a list of values. Now, as you see in the lecture notes, the multiplication table is ultimately a two-dimensional structure. It has a certain set of values for every column, and there's a number of rows that contain these values. You've seen for loops that let you do one thing over and over and over again, but how do I break that up into its constituent parts? Let's think about the multiplication table for just a little bit. Multiplication table, and let's just leave it at that. And this is only going to print. It's not going to return anything because this is something to be printed out. If I wanted to print the multiplication table, as you can imagine, I could print the values. So the top row would be all the numbers multiplied. The number 1 multiplied by 1, 2, 3, 4, 5, and so on. So I do 1, 2, 3, 4, 5, and so on. The second row would be, well, now these are the numbers 2 multiplied by that. 2 times 1, 2 times 2 is 4, 6, 8, 10, 12. I'll do one more. You know the hang of this, but I'll just do one more. These are the numbers multiplied by 3. 3, 6, 9, 12, 15, 18. Boy, this gets boring really fast, especially when you want to produce a multiplication table from a specific set of values, not just the integers. Well, the trick is to understand that you need to do two sets of iterations. One, you need to do something in the sense where you need to print a number of rows. One row, then 2 rows, then 3 rows, and so on. Now in every row, you want to print a number of columns. And so this leads to a structure that is two-dimensional, and in writing a program for that, you need to have a for loop that's nested inside of another for loop. Let me show you how it's done. So if I wanted to print out 6 different rows, or 10 rows, or anything like that, let's now make this a meaningful function. Multiplication table with a list of values. Now, to do this, I'm going to start with the idea, well, that the first row is going to be all the values multiplied by the first value in that list. And the second row is all the values multiplied by the second value in the list, and so on. So I know at some point I want to do something for every value in values, although it's not clear what it is that I want to do. I'll just make a quick comment to myself. Print out a row. Okay, get rid of these. Now to print out a row, I have to construct that row. And the row is nothing more than a particular value multiplied by every other value. I'm just going to make a quick little note here. Just save this and run it and see what it looks like. So my values, I'm going to say, are 2, 4, and 7, just to come up with something. So the multiplication table for that, right now it says I can print the row for 2, and then the row for 4, and the row for 7. Well, what would the row for that be? The first row would be 2 times 2 is 4, 2 times 4 is 8, 2 times 7 is 14. So I really want to print out 2, 8, 14. If you think about it, I want to do something 3 times. Well, that's exactly what a for loop does. I want to do something for every element in the list. This is looking really interesting. Let's try it. Let's print out the row, and the row is itself going to be constructed by, initially it's blank. When I'm done, I want to print out the row, and I want to do something for every element in the values. I have to come up with a different name of my variable. This is the variable val that's going to keep track of one at a time each element in values, and that's going to be the rows. And this element here is going to represent the elements that are going to represent the columns. Okay, we're getting closer. Let's take the row and let me append to the row the element. Let's put a comma in there just so we can kind of keep them separate. Put a space. Pretty good. Put a space in there to keep things separate. This structure is typical in programming, especially when you want to work with two-dimensional structures like matrices and arrays. Let's read it as best we can. I want to do something for every value in my list of values. It looks like I want to print a row. And my row starts out being empty. And I'm going to append a couple of values to the row until it's eventually done, and then I'm going to print it out. Now this isn't exactly the problem, but it's getting closer to the problem, so we'll take a look at that. This prints out each of the 3 values, and it makes a row. 247, 247, 247. Well, of course, now I've got the right structure, but I just have the wrong computations. And the basic problem is that I don't want to construct the row by appending each element. I want to construct the row by appending the product of different elements. Now we're getting somewhere. What is the product? Well, we already said that I want to have the values be the first one be 4, because that's 2 times 2. The next one be 8, 2 times 4. The next one's 14, 2 times 7. Well, if I could just compute the product, which is going to be the value for the row. The first one is a row for 2, the next one is a row for 4, the next one is a row for 7. That's actually the variable val is keeping track of that one. And then each element going across is going to represent the column, 2, then 4, then 7. So if I take the val and I multiply it by element, I actually have the correct computation for each individual cell of the multiplication table. And so I have 2 times 2, 2 times 4, 2 times 7. And then 4 times 2, 4 times 4, 4 times 7. And finally 7 times 2, 7 times 4, 7 times 7. As with any multiplication table, you know that the diagonal elements are squares, 4, 16, 49. And the other values are the appropriate computation. Now there's some formatting that I could do differently, and I recommend that you look at the lecture because I showed how to do that in a nice way. This will now take that basic structure that you saw dealing with ranges, and I've converted it into one that takes in actual values. The basic solution is a nested for loop. Now, I won't be asking for nested for loops on an exam. The basic reason is that sometimes it just takes a little bit more time to get your mind around the problem, and given a time constraint of an hour, I just think it's unfair to ask you to do that. However, you will see this again on homeworks, so please make sure you understand the concept, which is this. You know that a for loop lets you do something for any number of times. If you put a nested for loop here, then it's just like how you have a minute hand on a clock and an hour hand on the clock. The outer one is the hours, the inner one is the minutes, which goes 1 to 60, and then the second one, the outer one will advance to the next element or the next hour, and so on. It's a very common structure. You see it a lot, like I mentioned before, with matrices and with arrays. You need to understand it, and so I encourage you to review the lecture for today and make sure you at least attempt and understand this assessment. This completes the assessment for day 14.